My name is Jose Luis Lopez Cacalusuchi. I'm going to talk about the ellipse. What is an ellipse? An ellipse is a closed curve with two axes of symmetry that results from cutting the surface of a cone by a plane oblique to the axis of symmetry with an angle greater than that of the generatrix with respect to the axis of revolution. This is an ellipse. This is an example about ellipses. Those 2 points are called foci. The horizontal line, A, is called the major axis, and the vertical line, B, is called the minor axis. The center of the ellipse to the right of the foci is called A. On the left of the foci is also called A. To understand the ellipse, in this example, point B is seen to move the foci have a certain distance from the point B that forms a triangle. When the point is moved, the distance doesn't change. At the top of the image, you can see the question. We will use that. The A will always be greater than B. To solve the equation, we are going to apply the square root 2, 25 and 16. So A will be 5 and B will be 4. The C are the foci. To get it, we have to square A and B and we have to subtract and then apply the square root and the result is 3. And finally, this will be the graph. The ellipse is not a circle, but it is made up of two perpendicular traces between them, one of which is greater and the other smaller. In general, the vertical stroke is the smallest. Since the ellipse is usually longer horizontal than vertical, the conjunction of these two strokes is the center of the ellipse, and with them the center axis of the ellipse is formed. One of the characteristics of the ellipses is that if we trace any 2 points on any of the two aforementioned strokes, their union on the perimeter of the ellipses always form a conical or triangular figure. Depending on where these points are drawn, the lines may be longer or smaller or even the same if they are drawn at a similar distance from the perimeter. In some cases, ellipses can be the projection of the perspective of the circles. The ellipse is also usually described as a smoother curve, which makes it different from circle or semicircle. However, this doesn't mean that their axes are asymmetric, but that is ordered to maintain the ellipse's shape. The distance between the major and minor lines must always be maintained.
In mathematics, a parabola is the conical sections of eccentricity equal to 1, resulting from cutting a straight cone with a plane whose angle of inclination with respect to the axis of revolution of the cone is equal to the represented by its generatrix. Is called a parabola to the locus of a point moving in a plane such at equidistant from a fixed line. Grid line are called a fixed point in the plane, which does not belong to the parabola or grid line called focus. Geometric properties. Strict side. The line segment comprised by the parabola which passes through the focus and is parallel to the directrix. The focus is a singular point, general not belonging to it with respect to which certain distance relative to all points. Directrix, surface or volume that determines the generation conditions for another lines, surface or volume. So, for example, the trajectory of the bounce of a ball can be an example of the shape of the parabola, like that.
Hyperbola is an open curve with two branches, obtained by cutting a straight cone through a plane not necessarily parallel to the axis of symmetry, and with an angle less than that of the generatrix with respect to the axis of revolution. In analytic geometry, hyperbola is the geometric places of the points of a plane, such that the absolute value of the difference of their distances to two fixed points, called foci, is equal to the distance between the vertices, which is a constant positive. The hyperbola looks like an hourglass, since it has dual have statuen cut vertically, two branches appear in reverse. From a geometric point of view it is a set of points whose distance difference is always constant. Every hyperbola includes the following elements: the fixed points or foci, the secondary axis that is equivalent to the perpendicular bisector of the segment, the intersection point of the axis is the center and the vertices and the eccentricity. This element establishes a measurement of the opening of the branches of the conic. From the field of the history of science, the Greek mathematician Apollonius of Perga was the first to write a treatise on geometry dedicated to the conic sections. When the hyperbola has its center outside the origin it is the following formula. When the hyperbola is vertical its formula is as follows. When the hyperbola is horizontal its formula is as follows.
So, ladies and gentlemen, we have a parabola, or I'm sorry, not a parabola, we have an equation. We want to write it into our standard form, and then we want to plot the asymptotes and make a little sketch of the graph. How does that sound? That sounds fun. Okay, so the first thing is, again, if we know our definition of our parabolas, we need to first, before we can even determine if it's going to be horizontal or vertical, we need to at least be able to see what the graph is going to look like. So first thing we do is I'm going to combine my 4x squared plus 8x minus 3y squared equals a negative 16. So I put the constant on the other side, and I arrange my x's and my y's. And I do that because now I want to make sure that I can combine them, because I forgot to go over this. Let's go over the formulas, right, that we're trying to figure out. Okay, this one is x minus, no, this one would be y minus k. Okay, so we have our two formulas, and what we need to do is we need to make sure we can write this in that formula, right? So, first thing I need to do is now I'm going to have to complete the square. Before I complete the square with the x, I need to make sure I factor out a 4. I can't complete the square with my -3, but that's fine. That just means that my k is going to be 0, right? Now, I complete the square over here, so I have 8. Got to factor out a 4, so that's a 2. So I have 2 divided by 2 squared, which equals 1. So I have 4 times x squared plus 2x plus 1 minus 3y squared equals -16. However, ladies and gentlemen, notice that I'm not adding a 1, I'm adding a 1 that's being multiplied by a 4. So therefore, I'm going to have to add a 4 over here as well. So therefore, now I simplify, or I factor this down to its perfect square, or binomial squared. So it's x plus 1 squared minus 3y squared equals -12. Now, again, remember, both of our formulas equal 1, right? Both those formulas equal 1. So, let's divide by -12. We'll do this by both terms. Therefore, by simplifying this, I now have a -3 times x plus 1 squared plus y squared over 4. I'm sorry, that's a 3 on the bottom, right?
Well, so you make the top negative, not the bottom?
It doesn't matter. -4 divided by 2 is the
Why are you
same.
adding? I thought it was multiplying. Because.
The negatives divided by another negative makes a positive, right?
True.
So now, you're right though, this needs to be a subtraction problem, right? So rather than saying a negative number plus a positive, I can rewrite this as y squared over 4 minus x plus 1 squared over 3 equals 1. So you're right. Right? You want to write it in that format, because now when you have it as a subtraction, you know now that a squared equals 4 and b squared equals 3. Right?
How do you, okay.
Because it's always a squared minus b squared. For our hyperbola, a squared minus b squared. Huh?
A is always the larger one.
No, not necessarily.
Oh, God.
It's just always in the formula, a squared minus b squared. That's the formula that we're always going to have in this form.
So in hyperbola, it's not going to matter whether it's bigger or not.
You're not always going to have a larger or
But I
smaller.
thought you said that the A is.
On your ellipse, on the ellipses, that's the way that you're always going to have it. Okay?
So how do you know in here it's the same?
You just write it as a subtraction, one minus the other, and then whatever that is, what you're subtracting from, that's your a minus your b.
So it can be negative. It can be 4 minus 5.
Yeah, that was our last example, right? So now let's go and take a look at our h and our k. So if we know our h is now represents our, sorry, let's just do our center. So now I can say the center is going to be -1, comma 0. Yes? Yes, no, maybe so. Okay. So, ladies and gentlemen, if we have our 4 and our y, if our a squared is under our y, now this means we're going to have a vertical one, right? So, we know our center is at -1, 0. Okay? The vertices are going to be plus or minus 4. So therefore, if a squared equals 4, we know that a equals 2. So to find the vertices, ladies and gentlemen, are your vertices...
Pardon the interruption. Please turn your TV sets to channel 6 for the Mustang News.
Since this has a vertical transverse axis, our vertices are going to be on the transverse axis as well. So our vertices are going to be -1, comma, plus or minus 2, right? Which will be -1, comma, -2, and -1, comma, 2.
Wait, did we ever get formulas to how to figure out the vertices, or how do you figure out the vertices?
It's the same distance, it's a.
Okay.
So it's the same thing as an ellipse, it's just your definition of a. The only thing you need to know is it's on the same as your transverse axis. Remember ellipses, they were all on the same major axis? Well, now they're on the same, what we call a transverse axis. So the h is not changing in this case because you have a vertical transverse axis. The same thing now goes with our foci. Now we need to determine what the foci is. And remember the relationship we have for hyperbolas. I think that was a bad reason for you to come back in class at this point in time. Because remember the definition for the foci that we had was c squared equals a squared plus b squared. Well, we have a squared is 4 plus b squared, which is 3. Right?
You just need C squared though, not C, right?
Sorry?
Do you only need C squared, not C?
No, we actually need to figure out what c is. Because c is the difference, c is the distance from your center to your foci. So c is the square root of 7, so our foci are going to be -1, comma, plus or minus the square root of 7, which is -1 plus, or I'm sorry, -1, comma, 0. Sorry, 0 plus or minus 2, 0 plus or minus square root of 7. So,
Does
plus
that matter? Yeah, why is it?
because, yeah, of course it matters. That's a huge mistake. Guys, you're taking your center and adding the vertice to your k, to the k coordinate of your vertice. This one just happened to be c, so it didn't matter.
Yeah, but why, do you have to put 0 plus?
No, you don't have to, and that's why I got lazy and I didn't write it. But you need to understand you're adding it to the k form of your center. You just need to make sure you understand that. In this case, yeah, you're going to have square root of 7, and in this case you have -1 minus the square root of 7. Well, guys, you can write those in your decimal form. Square root of 7 is roughly 2.6457.13. I'm sorry, say that again.
Are you allowed to put negative square root of 7?
Because why don't you not take the square root of -7? But yeah, leave it in that exact answer. So your foci are going to be somewhere right around here. All right. Now, last thing, ladies and gentlemen, remember they're in between. They're between the center and the vertices are your foci. Now, that's an approximate value. The last thing, ladies and gentlemen, we're trying to do is find our asymptotes. So remember, for a vertical asymptote, we have y equals k plus or minus a divided by b times x minus h. So all we're going to do to find our asymptotes is plug in this values. So we have our k, which is 0, plus or minus a over b. So our a is 2, and our b is square root of 3. Times x minus h, which is -1.
You can just leave it as -1. Oh.
So then when I distribute that through, you're going to have that line. Oh, I'm sorry, and it's plus or minus, sorry.
Do we need to do the 3?
We will learn how to graph them, but we'll practice that next class period, just so you guys understand how to find the asymptote, okay?
Circumference. The circumference is a section conic. It is one of the simplest and basic geometric figures that we know of. We could define a circumference as the figure generated by a closed curve or perimeter in which are no vertices or internal angles. Also, the circumference does not have different sides as it does with other figures such as the square of triangle. Being a line, the circumference has only one dimension, the length. Parts of the circle. The circumference origin, who is the center of the circle. Diameter is a line segment that passes through the center of the circle and has its endpoints on the circle. All the diameters of the same circle have the same length. Radius is the line segment from the center of the circle to a point on the circle. The radius of the circle are all the same length. It is half the length of the diameter. Tangent is a line to which a circle at only one point. A tangent is perpendicular to the radius at the point of contact. The point of tangency is where a tangent line touches the circle. Secant line intersects the circle in 2 points. Finally, arc. An arc is a part of the circle. It can be measured in degrees. How to graph the circumference? You must know the equation of the circle. The standard form of the equation for a circle is x minus a squared plus y minus b squared equal radius squared. The symbol a and b represent the center of the circle as a point on the axis, where a is the horizontal displacement and b is the vertical displacement. The symbol r represents the radius. As an example, take the equation x squared plus y squared equal 16. Find the center of the circle. Remember that the center of the circle is shown as a and b in the equation of the circle. If there are no square brackets as an example, that means a is equal 0 and b equal 0. In the example, note that you can write x minus 0 squared plus y minus 0 squared equals 16. You can see that a equals 0 and b equals 0, and the center of the circle is therefore at the origin, at the point 0, 0. Find the radius of the circle. Remember that r represents the radius. Be careful if the r is part of the equation doesn't include a square. You will have to find out the radius. So, in our example, you have 16 times r, but there is no square. To get the radius, write r squared equals 16. Then you can solve it to check that the radius is 4. Now, you can write the equation is x squared plus y squared equal 42. Is incorrect. Draw the radius points on the coordinate plane for any number you have on the radio. The cone of a number is the fourth direction in the center. Left, right, up, down. In the center, in the example, you will have to count.
Alright, if we look at this, guys, here is going to be pretty much a general form for a conic, okay? So we can write all of our conic sections, a parabola, an ellipse, an hyperbola, a circle, all in this general form, alright? But we've also talked about standard forms, right? And I'm just going to go through one of them for each one, alright? And we'll kind of talk about it. So the first one we talked about was a parabola. Where we said a parabola we could rewrite as x squared equaled 4p Let's just do the x and k, that's fine. And actually let's do, so x squared equals 4py. That is a parabola with the vertex at the origin, right? So that was a parabola. Then we talked about an ellipse. And remember, ellipse had x squared over a squared plus y squared over b squared equals 1. We had a hyperbola, which was, let's just do this, x squared over a squared minus y squared over b squared equals 1. And then we also talked about a circle, where a circle is going to be in a special type of ellipse, but a circle is when a and b are equal to each other. So we can just use a squared for each one. Now, ladies and gentlemen, for these three examples, all right, some of these are verticals. Actually, these are all have a horizontal, right? This is where, this one's going to be opening up and down. This one's where you're going to have a horizontal major axis. This will have a transverse axis, which is horizontal, and this one is just going to be a circle. So this is just a little general form when I talked about parabola, ellipse, hyperbola, and a circle. All right. Now, obviously, you guys know there's another type of equation, right? You can have the equation where the parabola opens horizontally. You could have a vertical major axis. Here, you could have a transverse axis, which is vertical, which would be the other formula. But the circle, we notice, is kind of always going to be the same. We always know that our A is going to equal each other, right? We know that these two have to be the same. You have the exact same major axis and minor axis. They're equal to each other. So if I gave you a formula in this, or if I gave you an equation that was in this formula, how could you determine if it was a parabola, an ellipse, hyperbola, or circle? You could convert it to each one of these formulas, right? Or their other counterparts. Or you can convert it to each one of these formulas and determine it. Or there's a little bit of a test that we can look at. All right. Now, so what we're going to do is, to do this test, we're going to look at the coefficients of our x squared and our y squared, right? So what you guys notice is that really our coefficient of x squared is 1 over a squared, right? And here for y is also going to be 1 over a squared. So if you kind of remember, what we can do is, if the coefficients of my x squared and my y squared are exactly the same, meaning if a is equal to c, then you know you're going to have a circle. So if you look in an equation and you know a is equal to c, then obviously you know that your major axis and your minor axis are the same. So if you have a equals c, that's going to tell you you have a circle when you have a conic section written in this format. Let's look at a parabola. On a parabola, we only have one squared, right? It's either x squared or y squared. In this case, I have an x squared. So therefore, I would have a 0 as the coefficient of y squared. So if I gave you a formula in this format, a or c, one of them would have to be 0, correct? Yes, John? Correct? Only one of them has to be 0 because there's only one x squared or one y squared. So if you were to multiply a times c and you got 0, then you know you have a parabola. So what I would look at, if you're given a formula in this form, if you only have one x squared or one y squared, ladies and gentlemen, then you know you're going to have a parabola. All right? Now let's go and take a look at an ellipse and a hyperbola. Notice, ladies and gentlemen, that an ellipse, we're always adding, right? We're adding our x squared over a, or we're adding the x squared and the y squared. So therefore, if I multiply a times c, that value has to be greater than 0, right? Two positive numbers are always going to add greater than 0. So if you multiply a times c and it's greater than 0, that value, so if you find your a and c and you add them up, you multiply them, and if it's greater than 0, then you have an ellipse. All right? Now, remember, hyperbolas was subtracting, right? It's the same thing, but now you subtract. So therefore, what you really have is a positive coefficient times a negative coefficient. That means if you have a times c is less than 0, then you have a hyperbola. All right? So these are going to be your main points you guys are going to want to know. So if I give you an equation in this format, all you need to do is understand, if it's a times 0, then you have a equals 0, a times c equals 0, you have a parabola. A times c is greater than 0, you have an ellipse. A times c is less than 0, you have hyperbola. And if a is equal to c, then you know you have a circle when it's in this format. Okay? That's it. And guys, you're